Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about transformations, moving on to rotations. So we started with overall discussion of transformations. We talked about isometries. We discussed translations. And we talked about reflections. Now we're going to talk about rotations. All right, so objectives here you can read through. I'll notice them quickly. You want to understand the concept and vocabulary of rotations. You want to find the coordinates of a rotated point or an image given its pre-image coordinate, any center of rotation in a quadrantal angle of rotation, so increment of 90 degrees. Mastery would be find the rotated point for any non-quadrantal angle of rotation, which we won't cover in this particular lesson. We may do as an extension some other time. And then find the center of rotation given two sets of rotated points. All right, so definition and vocabulary. All right, so rotation, and I take this number 3 because we've talked about translations, reflections, now the third isometry here, rotations. Rotations, a turning of all points in a figure by a given degree about a given point. Now this rotation is not exactly to scale. Rotated figures keep their shape, so we call them an isometry. And here I'm going to rotate triangle ABC about the origin. So I can say the point or center of rotation, either one works. Commonly I'll use, at least in my abbreviation, COR to stand for center of rotation. So here I'm going to rotate the figure triangle ABC in a clockwise direction, and then a certain angle measure, and then it ends up as A primed, B primed, C primed, so my pre-image and my image rotating the triangle in a clockwise fashion. All right, so when we rotate an object or a point clockwise, it's going to be a negative rotation. So we can either say rotate figure ABC clockwise, or we can say rotate figure ABC negative degrees, whatever the degrees are. So clockwise number of degrees, or rotate negative degrees. When we rotate it counterclockwise, it's going to be positive, so we can either say rotate counterclockwise, the positive number, or rotate a positive number, and it'll indicate the same process. All right, so now we want to find the coordinates of a rotated point given its pre-image coordinate and any center of rotation in a quadrantal angle of rotation, and then we want to rotate that figure about a point graphically. Okay, so 90-degree rotation is about the origin. So what I want you to do is I want you to take this point 3, 4, my pre-image, and I want you to rotate it 90 degrees clockwise about the origin 0, 0, and provide the coordinates for the rotated points. I want you to use your intuition or prior knowledge to solve. I'm going to pause here, and we'll come back. All right, so you can see, so remember, when we rotate 90 degrees, if I were to draw a line segment from the origin, which is our center of rotation, our point of rotation, to the pre-image point, and then from the center of rotation again to our unknown image that's been the result of our rotation of 90 degrees, then I know these two segments are going to form a right angle. So I know it's pretty simple to see here because the center of rotation is the origin. The slopes of these two are going to be the opposite reciprocal values because they meet at a right angle. And the slopes actually also represent the coordinates. So here 3, 4 becomes 4, 3. So the change in y over the change in x. And we know then that the slope of this line segment has to be the opposite reciprocal, or 3 over negative 4. So we're going to find out the slope is 3, negative 4, and then we're going to convert that into a coordinate. And now sometimes it's a little confusing, or can be confusing, where to apply the negative value. And I rotate the point here. I find out the two slopes. I use the slope to find the coordinate, and then I apply the proper sign SIGN based on the quadrant we're in. So first, second, third, fourth. We're in the fourth quadrant here. Positive value for x, negative value for y. So here's y here, x here, and we end up at plus 4, negative 3. All right, so now we're going to rotate another 90 degrees. And again, this slope is the opposite reciprocal of this slope here to the first rotation. So now the second rotation ends up having a slope between the center of rotation and the rotated point to the center of rotation and the initial image. All right, so slope is -3/4. So we know the slope here is 4/3. It's in the second quadrant, so both values have to be negative. We end up with 4/3. Really, it's -4/-3, but we can call it a positive value. Negative over a negative becomes a positive value, and we can use these values in order to find our coordinate. Our coordinate is going to be -3, -4. All right, so now we're going to rotate it one more time in a clockwise direction, 90 degrees, and then we should end up with a slope of -3/4. So our slope is equal to -3/4, and our coordinate is going to be here 4, -4, excuse me, and +3. All right, so now I'm going to give you 2 other points. I want you to go ahead and graph these. I'm going to show you the answers in a moment, but I'm going to pause here. So I have A, B, and C. We've already worked on B. You can use the same graph. Let's see if you can find A and C as well. All right, so here is B. Here is A primed, A double primed, A triple primed, B primed, B double primed, B triple primed, C primed. This should be C double primed and C triple primed, and you can check your work. These are all rotations -90 degrees. So 90 degrees is a quadrantal angle. You can see the rule here is xy becomes y -x. All right, so now as we rotate this way in a clockwise fashion, xy becomes y -x. Now what happens if we rotate in a positive rotation? So we're now rotating counterclockwise. What is the rule? All right, so the rule is xy becomes -yx instead of y -x. All right, so here's our rule, -yx. And the way that I remember this is not necessarily for this rule, but you can use it. I just know that whenever I rotate 90 degrees, I'm going to change x and y, and then I need to identify the proper sign based on the quadrant that the rotated point ends in. All right, so the command then, if I were to rotate B to B primed, or B again to B primed in a counterclockwise fashion, my command would be rotate ±90 degrees about the center of rotation, which in this case is going to be the origin. Okay, so now we're going to rotate 180 degrees clockwise, and we can see that when we do that, we rotate, flip the values again, or switch the values of x and y, and so we end up with the same coordinates but different signs. All right, so our rule here is going to be xy becomes -x, -y. All right, so when you rotate 180 degrees about the origin, in this case, we're changing just the sign of the coordinates. Okay, so this is classwork. I want you to rotate 180 degrees about the origin. I'm going to go through this quickly. You can pause as you go along. Here is the answer. Write a rule for this rotation. Pause again. Here is your answer, rotate -90 degrees about the origin. Another question, rotate 90 degrees counterclockwise about the origin. Here's your answer. Write a rule to describe the rotation. Rotate 90 degrees counterclockwise about the origin, or just rotate 90 degrees about the origin. We're going to skip this point here. Okay, so now we're going to move on, and we're going to talk about rotating, or finding the center of rotation given 2 points on a graph. So let's move on and talk about that piece. Okay, so we're going to find the center of rotation given 2 sets of rotated points. Mastering this would be find the angle of rotation given 2 sets of rotated points. So any angle, find the angle of any angle of rotation given 2 sets of rotated points. All right, so here we go. So find the center of rotation given 2 sets of points. The set would be pre-image and image. All right, so graphically, let's talk about rotating a point. What are we doing when we rotate a point? A to A prime to A double prime to A triple prime, we're creating a figure of a circle. All right, so let's relate this to the circle. And we know that in a circle, definition of a circle is a set of all points that are equidistant from a fixed point called the center. So in circle language, we would say that the center of rotation to A is the radius, and the center of rotation to A primed is the radius, and that the length here is going to be the same distance from the center of rotation. So we know that the center of rotation to any pre-image and image is fixed. All right, and so we're going to use this knowledge to figure out the center of rotation given two sets of points. All right, so I'm giving you two sets of points here, A prime, so 4, 2, negative 2, 0. B is 1, 5. B prime is 1, negative 3. We want to find the center of rotation for these 2 points. All right, so what you need to realize is that the center of rotation has to involve that center where the distance from that center to B and the distance from that center to B primed, and that same point distance to A and A primed is going to be the same. Now that distance from the center to A might be 3, and the distance from the center to B might be 4. So they're not, A and B are not part of the same circle necessarily. They can be, but not necessarily. So we have to incorporate that fact. So I'm going to give you a hint, and the hint is let's draw the diagram for just B and B primed and identify all possible centers of rotation for B and B primed. And then we figure out what has to be true about a possible center of rotation. And what has to be true about a possible center of rotation is the center of rotation has to be on the perpendicular bisector of the line segment connecting the pre-image to the image. So if we were to take B and B primed and we were to draw all the possible centers of rotation for B and B prime, we know that they all have to be equidistant, right? And those points will end up on the perpendicular bisector of B to B primed. So how do we find the perpendicular bisector? Well, perpendicular bisector, first part perpendicular. We know that if we create a line here between B and B primed, that the perpendicular bisector is going to have a slope that's the opposite reciprocal of the line B primed. So B primed, we need to find the slope, and then we need to find the opposite reciprocal of that slope. That opposite reciprocal value is going to be the slope for the perpendicular bisector. Second, we know the perpendicular bisector, second word bisect, we know that the perpendicular bisector goes through the midpoint of B prime. So we find the midpoint of B primed. And now we have enough to write our equation. We know the midpoint is going to be 1, so 5 and negative 3 is 2 divided by 2 is equal to 1. So we know that the midpoint is at 1, 1 here, so it has to be 1. And then we use that point 1, 1 and a slope, which in this case is undefined, in order to solve for this particular problem. So y minus 1 is equal to undefined here. So we're just going to add 1 to both sides. Y is equal to 1. And that's the perpendicular bisector of BB primed. So now we need to do the same thing for AA primed. Right? Perpendicular bisector, we have to find the midpoint. And then we have to find the slope of AA prime. The opposite reciprocal is going to be the slope of the line that's the perpendicular bisector of AA primed. All right, so we find out the midpoint is going to be 1, 1. We find out the slope of AA primed is 1/3. We take the opposite reciprocal, it's negative 3. We write in point slope form, y minus 1 is equal to negative 3 times x minus 1. Y is equal to negative 3x plus 4. And then we're going to use the two systems to solve. We know that y is equal to 1. I substitute it back in for y. I solve for x. X is equal to 1. And then our center of rotation is 1, 1. That's it for this edition of Ot in Math. Come and join us next time when we talk about dilations.